Imagine your body as a high-performance biological machine. Proteins provide structure, while carbohydrates and fats supply the raw fuel to keep the engine running. But these macronutrients cannot operate in a vacuum. They require vitamins, invisible directors that facilitate the chemical reactions, allowing your body to actually use that fuel. When vitamin levels drop, the metabolic process begins to lose efficiency. Over time, energy conversion slows, immune responses lag, and brain signaling loses its sharpness. These molecules are required in tiny, almost microscopic amounts, yet they maintain the equilibrium of massive, system-wide biological networks. Modern lifestyles often create a paradox of nutrition. We consume a surplus of calories, yet frequently lack the specific micronutrients found in whole foods. Between indoor living and processed diets, our internal chemical stores are under constant pressure. Managing these internal stores requires an understanding of a single defining rule of chemistry: solubility. If we zoom into the bloodstream, we find the first major category, the water-soluble class. This group includes vitamin C and the diverse B-complex family. B vitamins act as metabolic engineers. They serve as essential catalysts, helping break down carbohydrates into ATP, your cell's primary energy currency. Because they dissolve in water, there's no long-term storage. Excess amounts are filtered through the kidneys and flushed out. This lack of storage means the body's supply is sensitive to daily intake. Without regular replenishment, water-soluble vitamin deficiency can begin to manifest in a matter of weeks. History recorded the results of these rapid depletions long before we understood the chemistry. Sailors without fresh citrus developed the bleeding guns of scurvy, while populations relying on refined corn suffered from pellagra, which triggers skin inflammation and dementia. Maintaining these critical levels requires a steady daily rotation of nutrient-dense sources, such as whole grains, raw nuts, and leafy greens. Water-soluble vitamins represent a daily metabolic requirement. Because your body cannot save them for later, your biology demands a constant, fresh supply to keep the engine optimized. Beyond the bloodstream, deep within the liver and fatty tissues, lies a different group, the fat-soluble class. These are vitamins A, D, E, and K. These vitamins require dietary fats to be absorbed. Once they cross into your system, they don't circulate freely. They are tucked away in the body's long-term storage vaults. Vitamin D stands apart in this group because its chemical structure and behavior mirror that of a hormone rather than a standard nutrient. When UV waves hit the stem's surface, they trigger a molecular transformation, creating vitamin D directly in the tissue, bypassing digestion entirely. These particles then travel to manage critical functions, facilitating calcium absorption for bones and supporting immune cell signaling. The same storage that makes these vitamins durable also makes their depletion hard to track. Deficiencies, such as weakened bone density or severely impaired night vision, develop very slowly over months, often without obvious early symptoms. For many, indoor environments have severed the link to natural vitamin D synthesis. This gradual drain on our reserves contributes to widespread reports of fatigue and seasonal mood shifts. Fat-soluble vitamins act as a biological reserve. While they are resilient against short-term gaps in nutrition, once those reserves are empty, the recovery process is just as slow as the decline. The body's ability to store these vitamins creates a unique risk known as hypervitaminosis. This diagram shows what happens during excessive supplementation. Unlike water-soluble vitamins, which have an exit through the kidneys, fat-soluble vitamins stay in the liver. When the storage capacity is exceeded, the overflow enters the rest of the body. This toxic accumulation can trigger severe reactions, including nausea, bone pain, and dangerous spikes in blood calcium that can damage the organs. Biological systems prioritize precision over volume. Once the body's specific requirements are met, additional intake provides no extra benefit and becomes a liability. Balancing these two systems requires a dual approach. Prioritize nutrient-dense foods for daily water-soluble needs, and seek moderate sunlight for vitamin D, while remaining cautious with high-dose supplements. Optimal health relies on the steady, daily calculation of these inputs. By providing the right molecules in the right amounts, we allow the invisible directors to keep